Okay, this will be your first exposure to elimination. And these are pretty cool. These first few problems most likely just stack up nicely for us. And in the problems we're told to use elimination to solve each system of equations. And again, at 5-1, you graphed. 5-2, you did a little substitution, and now we're going to see what happens with eliminating. But the idea is, like, if I have, 3x, and then I have 3x, well, I can't put those together and eliminate them. I would have to change one to be negative, and then they would cancel out. So that's what elimination is going to require. So the first one, if I look at 3x and 2x, those combined would get 5x. And if I just made one negative, it's not like they would cancel out, because if I subtracted it, I would still have 1x. But when I look over at negative 5y and 5y, those two are nicely stacked. And I know that if I were to take 5y and add it to negative 5y, well, they would go away. And it would mean that I would get rid of my y's. So in all of the problems you'll do, you'll have to rewrite these. So pause the video and make sure you get caught up and rewrite this problem. And with it rewritten, you want to make sure that your equal signs are in line, that your numbers are on the same side, and that your x's are below the x's and your y's below the y's. If they would have had these in reverse order, when we would have rewritten it, it would have been a good call to make them match up. So now that we have these stacked, let's look what happens when we combine these. 3x plus 2x gives me 5x. So I'm taking two equations and I'm combining them to be one. Well, negative 5y and 5y goes away. So if you'd like to, optionally you can write plus 0, but I think it's just a waste of time, so I'll leave it off. And then I'm going to write equals 15. Now, as you get more and more practice with these, you might see that, okay, I could have written 5x way over here instead, and just keeping it neater. Well, now you have a one-step equation that you divide, and you get x is equal to 3. These problems set themselves up nicely if you do them horizontally. So the next thing I'm going to do is over here. Because when I solve a system of equations, it's not enough for me to just say that x is a value. I have to also tell you what the matching y value would be. And when I look at these two equations and I decide should I plug the value of 3 into the first or the second equation, I don't know that it's all that big of a difference, but I'm seeing a smaller number in front of x's. I'm seeing, I'll eventually subtract rather than add, so maybe I just add it to the second one, or insert it in the second one. So here's 2x plus 5y equals 31, and I know that x is 3, so I'm going to plug a 3 in there, plus 5y equals 31. Simplifying things, I get 6 plus 5y equals 31, subtract 6, and the better you get at these, you'll do these in fewer steps. And you're going to get y is equal to 5. Now on purpose I'm trying to keep it to where you can see everything in one page, and the final step here is to summarize your answer. So since this is one coordinate x, y equals 3, 5. Box it. We should be thorough and check this work. 3 times 3 is 9, 5 times 5 is 25, and 9 minus 25 does give me negative 16. Same deal here. 2 times 3 is 6, 5 times 5 is 25, put them together, and yeah, you do get 31. Do these in a calculator if you need to double check your work. You want to make sure that as you're learning something new, you're getting these accurate. Okay, I'm going to clear the ink from this and I'm going to move it over. Okay, don't even think about the problem before you just write it. So your work, this will not be in the center of your page, this will be a new line below the last problem. Write down the problem. If you need to, pause it, get caught up. And like the last one, I see that this one stacks nicely. When I combine the x's, they're just going to go away, which means that 3y minus 5y will give me a negative 2y. And that's going to be equal to 2. Dividing both sides by negative 2 is going to give you y is equal to negative 1. That's not enough to do the whole problem, and so let's go ahead and cut a couple corners, nothing major. But if I look up here, I'm thinking, okay, I got a negative in front of that x, maybe I'll just avoid it. And so I'm going to write the second equation as 4x minus 5, but I won't bother writing y this time, I'll just write negative 1 times negative 1 equals 5. Which means that 4x plus 5 is what I get once I simplify it. And maybe you can look at this and tell that x is 0, but if not, we'll subtract 5 from both sides. And then say, okay, well, x is 0. Almost done, but not quite. We lastly have to say that x comma y is equal to 0 comma negative 1. And the reason for that is you were summarizing your answer and identifying that this is a solution to a system of equations. So let's double check our work. 0 and negative 1. If I go in and I check the first equation, 4 times 0 goes away. 3 times negative 1 does give me negative 3. It has to work in both of them. 4 times 0 goes away, and a negative 5 times a negative 1 becomes a positive 5, and this one also checks out. It's not enough, like I've said, to check only one equation. You would have to check both. Now this one, rewrite and see if you can do the first step on your own, and then come and see what I put. I'm going to put something up in about 3 seconds. The first question is this. Did you notice that they weren't in order? So I always choose to put something with an x first, so hopefully you rewrote it this way. Now, the final part of this, let's also make an OYO problem. So do this on your own, and I'm going to put the work below here in just a moment. Okay, so having worked it out, I'll go through here and just summarize all the steps. It's helpful to hear. This area here is just rewriting the problem, and rewriting it in the order that helps us. In the very first step, we notice that the y's canceled out, and that's what we're doing here is we're eliminating one of the two variables so that we go from two equations with two variables down to one equation with only one variable, and that means we can solve and figure out that x is 6. And of course, it's not enough to find only one of the two values, so we plugged it in either guy up here. I plugged it into the first one. Once we simplified, we were able to do a two-step equation and figure out that y is 1. And then lastly, summarize and check your work. 3 times 6 gives me 18, plus 4 times 1 is 18 and 4, gives me 22. Again, I get 18, but now I'm doing minus 4, and 18 minus 4 is 14. So this will be the first video before we head into problems where you have to write and solve a system of equations.